And then what you can ask is the following question, like, of course, it makes sense that people are different. Makes sense that some waiters dropped more dishes than others in this rather perilous job, having to dance while they were serving their customers. But why is that the case? Why would it be the case that some individuals end up making more of a mess than others? Why? That's the question we want to answer. We want to explain the variation in the data as well as possible. And perhaps we have at least a partial explanation for it. It is maybe one of the causes is that some were carrying more plates simultaneously than others. So what we will try to do is explain the variation in the dependent variable by looking at the variation in the independent variable. Perhaps the variation in the number of plates that the staff members usually carried is able to partly explain the variation in how many dishes they ended up dropping. In a Venn diagram, that's the visualization. In a Venn diagram, you can look at it like that. So the bottom circle represents the total variation in the dependent variable, in the accidents. And the more the plates variable is able to explain that variation, the more it overlaps with the accidents. So that's how the Venn diagram visualizes the strength of the relationship. The more overlap there is, the more the variables are correlated, you could say. And as a result, the total variation will be explained better and better by our plates variable, such that less unexplained variation will be left. All of that may sound a bit fidgety at the moment, like what do you mean by explained and unexplained variation? Well, you're about to see that. Let's zoom in on one participant as an example. I'm going to zoom in on participant number 6, like that. You can clearly see that that they were the messiest person in the restaurant at that night. Scored much higher than the mean on the accidents variable. That's also what the slide is now saying, drop more dishes than average. And what you see is that we partly expected them to do that. We have a regression line that says, well, the more plates you carry, the more accidents we expect you to cause. And so we could partly have seen this deviation coming. Part of the deviation from the mean, you could say, was already predicted by the trend line that we drew through the graph. As such, part of this individual deviation is explainable, is explained by the regression model, you could say. That's the green part. The green part shows that the participant deviated from the mean to some extent. If you carry this many plates, then we expect you to drop more dishes than average. That's how the general trend looks. And as a result, we can partly see where this individual deviation came from. The red part remains unexplained. This waiter dropped even more dishes than you expected from him based on the overall trend. And that must have something to do with individual characteristics of his. Maybe he was just more clumsy than the average individual. Let's try this another time. Take another participant. Participant number 2. Here she is. This was one of the more successful individuals. She didn't drop a single dish. And again, you can partly predict that. The regression model already predicted that to some extent. What we said was, if you carry around only 2 plates, then you can see from the trend line, we expect you to drop fewer dishes than average. So once again, we can partly explain why she was below the mean, whereas another part of that deviation remains unexplained and must as such be related to other factors.